Hi everyone, my name is Chris Gamble and I run the Supply Frame Hardware blog. Today we're talking to Parker from Macrofab. Welcome, Parker.
Hi Chris, thanks for having me on.
Yeah, it was great to have you. As people may remember, last time we talked about, the first time we did a DfM case study was actually with Thomas, who created the KBox. We are going to be talking about the KBox again today. And people may remember that Thomas uses Macrofab to do manufacturing for low run, and you guys are really optimized for that. Could you just give me a quick overview of the service in case if people didn't watch it or didn't quite catch what we were talking about last time?
Yeah, so here at Macrofab, we specialize in doing prototypes, small volume, up to 10,000 plus units. We can scale all the way up for y'all, for anyone that's basically doing small OEM stuff. Mm-hmm. Mostly electronics. We do build box, programming, testing, everything, all the way to drop shipping to your Kickstarter customers.
Right. And that is kind of what Thomas was working on. He was selling on Tindy and doing that same kind of thing there. And he showed all the assembly directions and stuff like that as well. So what we wanted to talk about today is some of the costs that were associated, because it's not like these are actually algorithmically calculated, a lot of the costs that are built into the BOM. So let's take a quick look over at the BOM, what we had last time. So this is Thomas' BOM showing all of the individual assembly costs here. I actually went through a lot of this on my own with putting it into FineChips Pro just to really look at the individual BOM costs, like the component costs. But now this is kind of the top level BOM, right? There's always tiers within BOMs. And so we wanted to talk about some of the, how to really optimize manufacturing, parts costs. Well, parts costs we kind of covered. So manufacturing, assembly, and then maybe, I guess the mechanical stuff we're going to talk about in the future. So can you tell me a little bit about that and how we might start working towards optimizing for assembly and manufacturing costs?
Yeah, so one of the big things like PCB pricing is reducing your square inches, all that's typical, how to reduce costs because you just use less material. Right. But a big thing people don't really think about is like your trace width and like basically tolerance specifications for your PCBs. Like 0402 resistors versus like an 0201, stuff like that. And
so is that baked into your? So when people upload this stuff to Macrofab and they're starting to get costs and stuff like that, you're saying it's the per part placement cost is higher for a more precise placement. Is that the idea?
Not for that. It's more of the implementations of like if you have an 0201, you have to have smaller traces.
Okay.
And so you have to go to basically a tighter trace width.
Oh, I see. So you're saying that on the actual PCB fabrication that you can use a
Correct.
Less tightly specified, so you can get a 6 mil space and trace board versus a 3 mil space and trace board, which would be incrementally higher. Is that kind of what you're talking about?
Yeah, because like our standard manufacturing for PCBs is actually 5 mil trace, 5 mil spacing, okay. And we do offer extended, but that costs more. But if you have small parts or like 0.4 millimeter BGAs, mm-hmm. stuff like that, you have to go to the extended. So if you can get away with the larger standards, mm-hmm. Go that route to help save you some money.
Definitely, and this is kind of using. It's always that balance point between using new technology, right? So someone who's using like a brand new smartphone sensor that might be readily available in the market, but is very, very hard to manufacture because it's like a 4-pin BGA or something like that. That's going to require a lot more finesse on the, like you said, the board creation, and then also placement, all that other stuff, right? So
yeah. One of the big ones is like USB TypeC, where actually going with the 3.0 standard is you have like 4 or 5 different differential signals, and to get them out of that connector, out of the 24-pin connector, you have to really squeeze down your traces. And so if you can, if you don't need USB 3.0, just go 2.0.
I see. Right. Use a USB micro, which you can just get the stuff out a little bit easier. You can get it at 5 mil, 6 mil, no problem, right?
Yeah. Actually, the TypeC connector does do USB 2.0.
Oh, okay.
Yes,
so you're saying
you
for the
can
signaling versus just the pin the pin pitch.
Correct. Yeah.
Okay. Interesting. Oh, that's really good to know, actually. So it's not just spacing, but it's also technology limitations, because that ultimately constrains how much stuff you can fit in an area because of complexity.
Correct.
So okay. So general rule: less complex, probably cheaper, right? And that's
Yes,
probably carried
yeah.
out. The extreme version I always think about is when you see these really low-cost power supplies, which are like one-layer phenolic boards, like really cheap. You know, it looks like it was etched in someone's bathtub kind of thing. But you could tell that they're very, very low cost. They've been optimized over time to be really, really low cost and still hopefully also meet their power requirements and everything like that.
Yeah, the big ones for those are, as you said, power supply boards, and also boards that go in like really mass consumer devices like TVs and stuff.
Oh, yeah. Right. Yeah, you see that on like forums like Reddit all the time. Oh, I need to fix my power supply on my TV. Well, you should probably just replace it, right?
Yeah.
Yeah. Okay. And then what about the through hole versus SMD or surface mount technology? How does that all end up playing out?
So surface mount is way less expensive to place on the board labor wise, and most of the time for most parts, that's the surface mount parts are less expensive because there's less material for the manufacturer to make.
Okay.
The one that's actually throws that out of a loop are connectors.
Okay.
Well, I was going to go into a little bit later on the bill of material page, where we'll look at like the labor between an SMT connector and a through hole connector, because a lot of times the SMT connectors cost more, actually quite a bit more, because they use different plastics that make it so it can survive 260 degrees C in the reflow oven.
Right. Okay, and actually that's a great segue into what about lead-free versus leaded? Are you offering both, or does it matter for you guys, or what?
So we're 100% lead free.
Okay.
We don't do any leaded stuff here, mainly because basically you have to separate. You basically have to have two separate lines if you're going to do leaded.
Sure. Right. Yeah, because it'll contaminate otherwise, right?
Exactly. Yeah. And we do periodic testing to make sure, because we have a selective solder, you have to basically make sure you're not getting any lead in it. Same thing with your solder tips,
right,
etc.
Yeah, that makes sense. Yeah, because selective solder is pretty much like a solder water fountain, right?
Yeah. It's a wave machine that's on a CNC machine.
Yeah. Right. Yeah, those things are amazing.
And actually, the big thing is when we get RMAs back, or we have to do rework, where we'll get a board back from the field and the user has modified the board, and trying to figure out, did the customer use leaded solder on it? Because actually here in the States, that's very popular for hobbyists, is to use leaded solder, but over in Europe, that it doesn't really exist anymore.
Right, exactly. Okay, and then so when people are uploading bills of material to your site and stuff like that, does it call out that there are leaded parts specified, or are like non-Rojas parts will be called out as not allowed?
Yeah, and actually it's in the bill of material page, it checks to make sure that your part is Rojas compliant, and it won't let you order if it's not Rojas compliant, because we can't handle non-leaded parts basically.
Okay. All right, that's good to know. And I mean, honestly, this is a rapidly shrinking problem in general. Most parts are moving towards lead-free, but it is possible. So that's good to know.
Yeah.
Okay, well, let's take a look at your setup here. You're going to show us an existing bill of material from. So we're not going to look at Tomas' page, just because this is a page that everybody has access to. So tell us a little bit about what we're looking at here.
Yeah, so this is the Mac Arduino, which I designed. The files are up on our GitHub here at Macrofab, and if you make an account at Macrofab, this is one of the sampled projects that you get to play around with. So it's basically it's all filled out, ready to go, so people can go look at it. So we're running the standard manufacturing over here.
Okay.
And so we actually can see if we bump it up to extended, it will actually affect the price.
Oh, interesting. Okay.
Yeah, so it jumped it up.
Right. So this is actually what you're talking about here. You're talking about actually starting to select different things. So if you go more layers, if you go to more fancier boards, stuff like that. And so actually, I don't recall from Tomas' project whether he had additional things on there, but it is possible that he did change some of the silkscreen color, stuff like that.
Yeah, and it's the same thing with copper weights. If you go to 2 ounce, it's going to jump up your price quite a bit.
Mm-hmm. Yep, definitely. Okay, that's great. So what else? What else were you thinking? Oh, I guess Stackup. So you can change PCB Stackup directly here, or how does that normally work?
So this is just showing our default Stackup. We do support custom Stackups, but you have to kind of get a custom quote for that. But this is just our standard Stackup, so that if you're doing RF design or doing an antenna, what the Stackup is, and so you can basically figure out what your impedance would be.
Gotcha. Okay, so this is just the FYI for the user and making sure that it's very clear that this is what you are going with, right?
Yeah, this is what you're getting, and we do impedance control. One of the things that I try to steer people through is impedance control is kind of pricey for low volume stuff. Mm-hmm. And so if you can get within a certain tolerance of it's acceptable for what your signal should be, then try to go without impedance control for low volume stuff. Okay, for high volume stuff, it's not really too big of a deal.
Gotcha. Yeah, because you're going to be buying by the panel or similar kind of things, right?
Yeah.
Okay, great. So, and I do recall, if I switch back to, I'm going to just look at Tomas' view here real quick. Okay. So he had parts, assembly, and manufacturing, and he broke these out in that way. Is that similar to what you're? So there's assembly down here as well. So there's a total assembly. There's and that was, let's see, 1117. There's PCB assembly, which I assume is just placement and similar. Anytime you get a board assembled, that makes sense. And then PCB manufacturing, that is actually the PCB itself, right?
What was that last one?
The PCB manufacturing, like that is the cost of getting a PCB fabricated. So low run, 4-layer kind of something like that.
Yeah, so our interface breaks out, and you basically get the PCB cost per unit, parts per unit, and then you get the labor cost.
Got it. Could you show us that on this one then? I guess it's kind of jumping across, but yeah.
Yeah, it's right here. Okay. So up in the upper right, you get the total cost, and then when you go over here, it will break down the PCB cost, part cost, and then the labor cost.
Oh, interesting. Okay.
And all this stuff will change if you type
of course.
You want 100 of these guys.
Wow. Okay. Yeah. Oh, yeah. And I guess it does show that first it's calculating just multiplying it by 100, but then it's applying the price breaks as it looks at the cost of each part and stuff like that.
Exactly.
Okay.
Yeah.
That's good to know. So
it'll adjust your lead time as well.
Ah, interesting. Yeah, and that's a good point too. We've talked about on the Supply Frame Hardware blog, we talk about lead time a lot, mostly from the part from the part ordering side of things. But in this case, this is actually the full assembly and stuff like that as well, right?
Exactly. Basically, that date will be when it leaves the fab here.
Mm-hmm. And then shipping and all the usual logistical stuff. Okay,
yeah,
that's good to know. So what are some things that people can do to optimize some of the PCB costs?
About PCB cost?
Mm-hmm. Oh, I guess some of that we just talked about, right? So So some of it, though, I guess the thing that's not showing here is the outline of the board. That's one of the bigger ones as well?
Yeah, so that's over on the PCB tab, so we can go over there.
Okay.
So the good thing to look here is because we can look at all your layers here.
Okay.
And the trick is with this is basically just look at them to make sure everything got uploaded and converted into Gerber format correctly, and so you don't slow down your lead time.
Okay.
Because a lot of times, let's go to a point for the board outline real quick, because this is where we like to put your milling information. So this is the USB connector over here.
Mm-hmm. Yep.
And so you can see it's in there. And so if you're checking your connector and it's not there, you probably should go look at your design files and figure out why that didn't get imported correctly.
Got it. Okay. Yeah, and I guess the question I'm asking is kind of about the total size. So if we talk about like the size of a PCB, and you'd have to go and upload a whole new set of designs and stuff like that, because obviously you're not going to just change the outline, right?
Yeah.
So that is something to note. But that is one of the things that is correlated directly with PCB costs, just because of amount of material and stuff like that.
Material.
Yeah. Okay. And then is the total PCB size associated with the PCB assembly cost, or is that simply number of placements, or the number of sides of placements, that kind of thing?
Yeah. So the PCB assembly, we basically do it by per pin. And so you can have a ginormous board with one part on it, and it won't cost you any different than a small board with one part on it.
Okay, great.
Our process, we basically assume the worst case for basically high density design stuff.
Okay. Yeah, I guess that makes sense, right? If you have a 1-inch board with a bunch of BJAs on there, that's a significantly more complex design versus, like you said, a 10-inch by 10-inch board with a an SOIC 8 on there, something like that.
Yeah.
Okay, well, that's good to know. So people.
So that doesn't. So that doesn't influence your labor price here.
Okay. Right. And so and really, I think the main thing, like you said, I mean, people can go on here, play around with quantity. Obviously, it's a little bit more, a little bit bigger of a hassle if you want to try out different board sizes. But you do have different example project. You have this example project, so you can compare this one versus one that people upload, stuff like that. Tell us about the house parts as well, because that is another thing that Thomas mentioned.
Yeah. So the house parts we basically have a collection of resistors and capacitors that you basically get to place them for free. So you just pay for the part itself. And we usually, for the part pricing, is we get you the next price break as well. So if you want 1 unit, you get the 10-unit price.
Got it. Right.
If you have 10, you get the 100-unit price. And basically that just actually makes it easier for us to place them on the pick and place machine. And so instead of getting a little tiny piece of cut tape, we have a whole reel of that stuff already.
Right, and this is actually akin to almost any other manufacturer I've ever heard of. When you're doing assembly, it's better to have stuff that's already on the line. It's just that in this case, you have a house part number associated versus when I think about assembly jobs that I've done in the past, it's just like, well, just, all the decoupling caps.
Panasonic resistor.
Yeah, exactly. Right. 0603, if it's, 5% or better, I don't care, right? As long as it's, the value itself, right? 10K, and 5% or better, fine.
And the idea behind the house part numbering is because it's like MF, Res, 0805, 10K. It's easy to search and easy to find the part you're looking for instead of like, now I need the 0805, 10K. What's that Panasonic number? That's that.
Right, and that is a struggle for a lot of people, especially people that are coming into the field, right? Understanding that each part does need a manufacturer part number, but in this case, you're effectively abstracting that out. You're saying that if you use our number, we'll put down whatever's the best deal for that day or whatever you were sourcing locally. Again, what a lot of assemblers do, it's just that this is more kind of upfront for users.
Yeah, and a lot of people will have mark like R1 substitutions are okay for that.
Exactly.
Stuff like that. Yeah. You just need a Jelly Bean 10K.
Exactly. Yep. Great. So this is great, and this is kind of the there's other services out there doing similar kind of online things. You also do the placement, right? So can you show us that real quick as well, like the user verified placement stuff?
Yeah, I'll go over to that guy. So this is the last thing that you do before you order.
Oh, sorry, I should actually show this. I'm like busy staring at the screen. I'm like, oh yeah, this is great.
And so I wonder if this is going to. We've got a full screen mode, but I think it might take over my entire computer if I do that.
Yeah, probably not set up for our video. So
yeah, let's see if I can. Well, so yeah, this way you can make sure all your placement data looks right. All the bounding boxes are on the parts. I don't think this board's got bottom side parts, so we'll go ahead and just confirm that. Yeah, there's no bottom side parts.
Okay, and this does polarity stuff like diodes and stuff like that too? Do you have to check that?
No, we actually extract that data. We used to have users confirm rotations and stuff, but now we kind of do it automatically.
Okay, yeah. The power of the internet, yes.
Yeah.
Okay, that's great, yeah. And I guess that's probably even easier if it's using one of the, the Jelly Bean diodes, right? Like a 914 or whatever's listed on your house part list. So, okay, that's good to know. What about the cost of, is it, so it's like, can people optimize by putting, if say they're going to put 20 parts on a board and 2 of them happen to be on the bottom of the board, is it going to be like, well, putting it on the bottom then doubles the cost of assembly? Or is that another optimization they can do?
So because of how our process is here at Macrofab, we because we will basically batch prototypes and small volume orders together.
Okay.
So those basically every single panel goes through both sides. And so there's not really any cost savings, at least with us. There might be with other manufacturers.
Right, where you're running the whole, so if you're running one board, you might as well run, so like, if you have your own panel and you're only using 2 by 2 inches of it, but you still have to use the whole panel, and then so you would have to do another loading cost for run it through the top side, flip it over, run it through the bottom side, right, that kind of thing.
Yeah, one thing to look out for that is to make sure, because like, when you flip a board over and then run that through the reflow oven, you got to make sure that your heavy parts are on your top side of your board. Because the bottoms get run first. Got it.
Okay. Yep, that's good to know. Okay, cool. Well, anything else we should know about this and what people should be looking at here?
The placement screen?
Yeah.
Don't think so. We'll take a look at the bill of materials if you want to. We got some pretty interesting stuff I think that y'all didn't cover last time.
Yeah. Like what stuff?
We got this. I don't know if y'all looked over our price risk matrix.
I don't think so.
This is pretty cool. Basically, a part that's good for volume stuff or prototypes might not work for large volume stuff because there might not be enough in stock, or the price breaks aren't as good as another part.
Ah, okay. So this is actually another great, DFM kind of thing anyways. So yeah, tell us more about that.
Yeah, so this is the 47 picofarad capacitor that's on the Macrofab. I think we have 2 of them on the board. And so we're going to search for some parts. So it's going to search for the part number that I punched in there. So let's say, okay, we want to get a better price for that. So we're going to look for some 47 picofarads that are 0603s.
Okay, so this is kind of taking it to a parametric level search and just kind of looking for what's out there, and this will, like you said, it also might look for house parts as well.
Yeah, if it could find a 47 picofarad 0603, we don't have one for a house part, but it would actually suggest house parts first.
Okay.
Because they're generally actually the best deal out there.
Yeah, I assume, yeah. Okay, so it's just kind of cost optimizing based on all the API stuff that you're searching through, right? And then once you have that, then you can say, well, here's the best price, and yeah. Oh. We're loading down our computers. I realized that my phone call was on before too, so hopefully people
there goes.
Yeah, will forgive us for that. Okay. Oh, cool. So this is basically showing risk versus price, obviously.
Yes. So it's looking at what's in stock at all our approved vendors. It's also looking at what's on order at those vendors and the price. And so it's saying that, because I'm using this guy down here. It's actually saying that this guy, this CC0603 guy, is actually what I should be using in terms of price. And this is actually the fully baked in price with
placement and everything, yeah.
With placement installed.
Okay, yeah, no, that's nice too to actually pull out the placement side of things as well. What about what about like tolerance and voltage and stuff like that? Or I mean, I guess even here we're showing NP0 versus C0G. So considerations around material type, stuff like that. Is this again like a switching up for Jelly Bean stuff?
Yeah, this is mainly for Jelly Bean stuff.
Okay.
I don't know if compare part attributes is going to work. Oh, here we go. Yeah. So this way we can also look at the tolerances and other important stuff.
Okay, that's great. Yeah, especially voltage rating. Yeah, that could be a big one where, this is actually something where this is a feature that kind of starts to replicate what a lot of purchasing agents might do on a larger scale, right? But there's always that risk of, decoupling the part choice from the designer, right? Where there might be that one thing that is really necessary. Again, this is why you would do it for Jelly Bean versus, and when we say Jelly Bean, we should probably define Jelly Bean. Jelly Bean being, less important, kind of run-of-the-mill parts that are, similar things that are not mission critical, right? But they still have to be there. So yeah, like a pull-up resistor. That's a great example of a Jelly Bean component. You probably don't care about the tolerance or it really, as long as it hits the size and the, a rough value, then you're in good shape. So,
yeah.
And so, yeah, this is good. So what is the risk aspect here then? So risk being like orderability,
chances,
sourceability?
Yeah, availability for the parts. Like if you actually look at the one I have selected, if it says there's only actually, never mind. Actually, the vendor just got in stock. So yesterday when I looked at it, there was like 2,000 in stock.
Got it.
Now there's 819,000 in stock.
Right. So what you're really saying is this is based on availability of stock in the marketplace, right? And this is similar to things that when I did a BOM analysis with the FineShift Pro tool as well, it showed that same kind of risk around showing risk around, is it sourceable? Is it I'm going to get stuck tomorrow and then I have to go and hold the whole assembly because this one part that I specified this exact part that the whole thing can't proceed. And that's really the ultimate risk there.
Yeah, and the great thing about this price risk matrix is we're currently using it to look at other parts that are similar attributes, but you could also look at, like, let's say you need this one LED that's very specific.
Makes your design, right? Yeah, it's that.
Makes your design
perfect purple.
And there's no substitutions because no other parts fit. You can actually pull up the price risk matrix and you can see, hey, if I build 1,000 of these, I can't actually build 1,000 because those parts don't exist.
Right. In distribution, you might be able to wait 8 weeks and order from the factory, and actually that is something that Thomas mentioned as well. Of what do you guys call it? You hold stock for users, right?
Yes. Yeah.
Yeah. So what is it? Consignment? I guess that's what it's usually called.
Yeah. So you can consign a part basically if we can't buy it from Mouser, DigiKey, or Arrow, or whatever. You can actually just consign a part and ship it in, and we'll put it on your board.
Okay, that's great. Yeah, that's good to know. Awesome. Well, this has been a really great look at this is a good tool for low volume. It seems like even moving into high volume as well. It's just about basically anyone who is building a new design is going to do so and try and optimize their costs for the whoever they use.
Whoever's going to make it,
Yeah, and so this is great to have. Since Macrofab is mostly a hands-off model, being able to talk to you up front is great for people who are thinking about using it. So, anything else people should know? Where they should go online? What they should know about?
I think that's it.
Macrofab.com might be a good start, but people can get a free account and try uploading a BOM today.
Yeah, and we got a Twitter page at Macrofab as well.
Great.
So.
Okay, awesome. Well, thank you, Parker. We'll definitely check this out. We'll encourage people to try it, and we'll take a look at more DfM case studies in the future.
Thanks, Chris, for having me on.
Yep.